Schneider Electric is proud to sponsor this podcast series. With a purpose to empower all to make the most of our energy and resources, our mission is to be your digital partner for sustainability and efficiency. At Schneider, we call this Life is On. Know more at se.com/au. My name is Jo Taranto and I'm joined today by Neil Palmer, the Chief Technology Officer at Osmoflo, and we're talking about the role of water in green hydrogen generation. Neil, thank you for joining me.
Thanks, Jo. It's a pleasure to be here.
Neil, tell me a little bit about Osmoflo.
Yeah, Osmoflo is the largest headquartered Australian desalination company. It's been around about 32 years. Started off as a private company, but now is owned by Hitachi Zosen, a Japanese company. And we have a factory in Adelaide, about 250 folks here and overseas. And we've built about 600 plants. And one of the more recent ones is a small demineralisation plant, which provides hydrogen to Hydrogen Power SA at Tonsley in a small pilot experiment. So I guess we're dipping our toe in the water of the hydrogen industry, but we're very interested to see how it develops.
And Neil, you're responsible for engineering design and the innovation and also research and development work. Can you tell us a bit about the work you've been doing with the Hydrogen Park South Australia project?
Yeah, this was a couple of years ago. We tendered for a job with Siemens, who have a hydrolyzer, which was developed at Tonsley. That's an innovation park down near Flinders University in South Australia. It's a fairly small unit, but we've built the fully automated small hydrogen feed water system using reverse osmosis of mains water and then a non-renewable resin bed to produce very, very high quality water. And the reason for this is that when the electrolyzer produces hydrogen and oxygen, if there are impurities in the water, will they cause the hydrogen and the oxygen to be not quite as pure as it should be. This gas is then taken and it's by an organisation called the Australian Gas Infrastructure Group that's experimenting with inserting it into the local reticulation main. So it goes in at about 5%. So that's been going for a couple of years as a pilot plant, demonstrating that hydrogen can be used for, I guess, sale and municipal purposes.
And for those who don't know, Neil, how does the creation of green hydrogen work?
Well, it's fairly simple. Water is made of H2O, so there's two hydrogen atoms, one oxygen. We put an electric current through it with electrodes, and at one of them the hydrogen comes off and the other one the oxygen comes off as gas. These are separated, the hydrogen is stored, and then later it's used in a fuel cell or it can be burnt, and the end product is water. So there's no carbon dioxide involved in this process. So that's green hydrogen, but to make green hydrogen, you do need a very high purity water supply.
And we also hear something thrown around called blue hydrogen. What's the difference between green and blue hydrogen?
Yeah, blue hydrogen originates from methane, coal bed methane generally, and they mix it with very, very superheated steam, and that splits the carbon away from the hydrogen to produce hydrogen, but one of the byproducts is carbon dioxide, which then has to be dealt with and sequestered or stored. So it's not quite as clean. It's cheaper than green hydrogen, but then you have to deal with the carbon dioxide.
It seems to sort of defeat the purpose of why you're doing it, I guess. Can you tell us about what the impact of the pilot at Hydrogen Park South Australia has been? You talk about it being a pilot, but it certainly has shown some interesting, I guess, emission savings for a start.
Yeah, I think initial work mixes about 5% hydrogen, so that displaces methane, which is normally present in natural gas, and so therefore when the hydrogen burns, it doesn't produce carbon dioxide. So at 5%, it's fairly small. I think the pilot plant now for those houses, I think it's about 700 houses are reticulated. it saves about 13 tonnes a year. I think the intention is to increase it so that the hydrogen content increases, and ultimately it might save about 1,600 tonnes of carbon dioxide per year to about 1,500 houses. So that's fairly small at this stage, but it's a start. And I think if they go beyond that, then they've got to change the way that the burners work in appliances. But at this stage, let's see if it works. So we've been delighted as Osmoflo to be part of this project, because I guess we're dipping our toe in the water for what could be a pretty big industry.
And why is, as you mentioned, the water that comes from a desalination plant like yours so critical to make a renewable energy like green hydrogen?
Well, one of the problems, of course, is that with every kilogram of hydrogen that's generated, you need 9 litres of water. And that's because H2, the hydrogen, is the smaller molecules and the oxygen are the bigger molecules. And that's what they call the stoichiometric relationship and the chemistry of it. So therefore, a lot of water is needed to generate hydrogen. And as it's high purity water, it is possible to generate it directly from seawater, but it's more like what they call a chlor-alkali process, where you get caustic and chlorine generated as well, that are separate products. It's not quite as straightforward, but it is possible. But in this case, we've taken mains water, then we basically removed, and it's just like, I guess, distilled water that then goes into the hydrolyzer, and that produces the purest form of hydrogen.
How much water is needed to generate green hydrogen, Neil?
The relationship is about 9 litres of water for every kilogram of hydrogen that's produced. So, roughly unto 10 times as much water as the hydrogen that you get. So a lot of water is required, but the hydrogen is quite dense in terms of energy. And so therefore, the relationship with water and energy becomes an interesting one. It's not the cheapest, but I think in terms of environmental sustainability, it's very attractive. And there's a lot of investment being put into it. For instance, the South Australian government, which has sort of initiated this hydrogen park concept, is proposing a $750 million hydrogen plant at Whyalla, and that's quite an imperative of the South Australian government. I think they see the benefits of South Australia is that we've got a lot of wind and a lot of deserts and a lot of solar energy. So what has been a disadvantage in the past in terms of renewable energy is becoming quite an advantage, I think, for us. So, but it's not just stops there. Fortescue Future Industries is interested in Liberty One Steel. There's quite a number of players that are investing towards the upper Spencer Gulf, Port Augusta, Whyalla, Port Pirie area, where there are a lot of opportunities for generation of both wind and solar power. There's even a greenhouse there called Sundrop Farms. It's a 20-hectare greenhouse. It's completely solar powered with a solar tower and thermal desalination of seawater, and that produces about 20% of Australia's truss tomatoes. So there's tomatoes grown in the desert. Who would have thought? But things are changing pretty rapidly.
You're listening to the Australian Water Association podcast series, and I'm speaking with Neil Palmer from Osmoflo. And so you've got a renewable energy zone. It's really, I guess, quite an innovative hub. Is there a challenge with green hydrogen in storing and transporting it?
Yeah, that's a really good point. There's a number of methods. One of them is to create ammonia that can be created, which is nitrogen and hydrogen, and it can be cracked and it can be transported easily. To transport hydrogen to liquefy it is quite difficult because it has to be cooled to minus 253 degrees C, which is not far off, Kelvin zero. Once it's then put in a container, it has to be very well insulated, so it can be transported as a liquid form. Another idea that came from a South Australian petroleum reservoir engineer was to put the hydrogen into exhausted coal bed methane fields. So we're storing the hydrogen underground. The big thing of being able to do that is that you can create the hydrogen when energy is cheap, like in the middle of the day, there's lots of wind, lots of sunshine, and usually surplus power requirements. That becomes the cheapest. But if the hydrogen can then be stored economically, it becomes like a pumped hydro or like a big battery, so that when it's nighttime and the wind's not blowing, there's a potential to make energy by a fuel cell or burning hydrogen.
You talk about the hydrogen industry really integrating the electricity and water sectors. Do you think that the hydrogen, developing green hydrogen in Australia is important?
It's certainly attracting a lot of attention at the moment. I think it's considered technologically to be one of the easiest ways of producing hydrogen, but it has got quite a significant cost penalty, and I think it's 5 or 6 times the cost of for instance, methane. And then there's the storage issues. If it's able to be generated, I think the interest of Fortescue Metals Group, and I think there's a number of initiatives that they've got across Australia, is certainly powering vehicles, transport, trains, aeroplanes, because they're the ones that can't be powered by electricity and batteries easily because of the size required. So while batteries continue to be a sort of a mainstay of, I guess, cars and developments and some trucks in the future, I think because of the constraints on supply of materials that go into batteries, like the lithium and graphite, this is another way of generating where you need energy, which has got to be renewable energy going into the process, and that creates hydrogen, which is an energy source that can be stored and transported. I think that's the attraction for it.
What would you like to see next, particularly for desalination companies like Osmoflo? Where do you think the opportunities lie?
Well, as these larger projects go ahead, there will be a need for desalination. As I mentioned, the Whyalla one, I think there's a proposal for a large seawater desalination plant. The problem is where the energy comes from, which is the drier areas of South Australia, for instance. Inland, of course, they're dry and there's no water supply. So having a fresh water supply, and perhaps an ideal place is Norway, but Norway doesn't have the energy resources. So I think that seawater desalination is a first step, and then there's a second step, which is the demineralisation, usually by electro-deionisation, is the process that we generally use here to produce this high-quality water, and the price of that has to be built into the price of hydrogen. But as we go forward, the price of, I guess, doing nothing and the impact on climate change is something that obviously weighs heavily on people's minds.
It's certainly an amazing time of change, and it sounds like immense opportunity, Neil. Thank you so much for your time today. I've been speaking with Neil Palmer, the Chief Technology Officer at Osmoflo. Thanks, Neil.
Thanks, Jo. It's been a pleasure.